Hey everyone, welcome back to AI Paper Podcast. Today we're going to be taking a deep dive into a paper that I think has the potential to really shake up the way we think about LLM reasoning.
Yeah.
It's called Chain of Draft, Thinking Faster by Writing Less.
Oh, very interesting.
Yeah, so I love that title.
Oh, right. When I first saw it, I was like, oh, this is going to be good.
Yeah.
And it definitely did not disappoint.
It's a really intriguing concept.
Yeah.
The authors, Soleil Zhu and their team at Zoom Communications, they present a pretty compelling case, I think, for why conciseness might be the key to unlocking even greater efficiency and performance in these large language models.
Yeah. I mean, it really speaks to something that I think we can all relate to, right? Which is sometimes less is more.
Yeah.
So before we get too deep into the weeds, for those of you who are tuning in for the short form version, here's the gist. Chain of draft is a new technique that aims to make large language models, or LLMs, much more efficient when they're doing complex reasoning tasks.
Right. And the key idea here is that it's actually inspired by how we as humans think.
Interesting.
Instead of, we don't always think in these like long, elaborate paragraphs, right?
Yeah.
We often use concise notes and mental shortcuts to sort of guide our thinking.
Right.
And so Chain of Draft encourages LLMs to produce like minimalistic, information-dense outputs during their reasoning process.
Very cool.
And this can lead to some really significant reductions in token usage and latency.
That's huge.
Yeah, we're talking, up to 90% reductions in some cases.
Wow.
Without sacrificing accuracy, which is huge, right?
Absolutely.
Because, if we can get our LLMs to be, faster and cheaper to run, that obviously opens up a ton of possibilities.
For sure.
So, if you're working with LLMs for anything that involves reasoning, whether it's problem solving, question answering, even code generation,
Right.
this paper is definitely worth a closer look.
Yeah.
All right, so now for everyone who's sticking around for the full deep dive, let's unpack this a little bit further.
Okay, let's do it.
When I first saw that title, Thinking Faster by Writing Less, it really struck a chord with me.
Yeah, me too.
Because it just seems so counterintuitive,
Yeah.
right?
Yeah.
Especially in the world of LLMs where, we've been kind of pushing for more complexity, bigger models.
Yeah. More data, more compute.
More data, more compute, right? And this is kind of saying, well, maybe we should actually be going in the opposite direction.
Yeah, it's a fascinating shift in perspective, for sure.
Right.
And it all stems from addressing kind of this core inefficiency that we've seen in how we've been approaching LLM reasoning for a while now. We've seen, the success of chain of thought prompting, where the model kind of breaks down a problem step by step.
Right.
But as you know, those responses can get incredibly long, and that leads to increased latency and computational cost.
It's almost like it's overthinking it, right?
It is.
It's like you ask someone for directions and they give you a detailed history of the entire city before they finally tell you how to get to the grocery store.
Right.
You'll get there eventually, but it's not the most efficient way.
Exactly. And that's where the brilliance of chain of draft comes in.
Right.
It's about stripping away that unnecessary verbosity and focusing on the essential information that the LLM needs to reach a solution.
So let's get concrete here.
Yeah.
How does this actually play out in practice?
So a good example is the paper uses the simple Lollipop problem to illustrate the difference between standard prompting, chain of thought, and then chain of draft.
Got it.
So imagine you have a problem like Jason has 20 lollipops.
Okay.
He gives some to Denny and ends up with 12. How many lollipops did Jason give away?
All right, classic word problem.
Right.
Simple enough for us to understand.
Yes.
But maybe a little tricky for an LLM to articulate.
Exactly.
Yeah.
So with standard prompting, you might just get the answer 8.
Right.
No explanation, no insight into how the model arrived at that answer.
Just the magic number.
Chain of thought, on the other hand, would give you that step-by-step breakdown. Something like, Jason started with 20 lollipops. He gave some to Denny. He now has 12 lollipops. Therefore, he gave Denny 12. 12 equals 8 lollipops.
Correct, but definitely verbose.
Yeah. I mean, it gets the job done, but it feels like the model is,
It's overthinking it.
it's overthinking it a little bit, right?
Now with chain of draft, the response is beautifully concise. 20x equals 12, x equals 20, 12 equals 8.
Wow.
Just the essential equation.
I love it.
needed to solve the problem.
So it's like the LLM is learning to think in shorthand almost.
Yeah.
Right, just cutting straight to the core of the problem.
Exactly.
And that's where things start to get really interesting.
Yes.
Because the researchers didn't just stop at the theory here.
Yeah.
They actually put chain of draft to the test.
They did.
Across a variety of tasks.
Absolutely. And the results are really what make this paper so compelling.
Okay, so let's dive into those results.
Yeah, let's do it.
Yeah.
They tested it on 3 main categories of reasoning tasks.
Oh.
Arithmetic, common sense, and symbolic.
Okay, a real trial by fire. Yeah, they wanted to see how it would perform across a range of challenges.
So let's start with the arithmetic reasoning tasks.
Okay.
They used GSM-8K for this. Right. That's the one with all those tricky grade school math problems.
Exactly. GSM-8K is a great benchmark for this because it requires the model to not only understand the problem,
Right.
but also to kind of figure out what steps it needs to take and then perform the calculations correctly.
Yeah, you really got to think like a little kid again.
Right.
Yeah, and I'm guessing standard prompting probably didn't do so well here.
You guessed right. Standard prompting for both GPT-4o and Claude 3.5 Sonnet.
Okay.
They struggled a bit, only achieving around 53% and 64% accuracy, respectively.
Oof, not great.
No, not so good, but as expected, Chain of Thought really boosted their performance,
Right.
pushing both models to over 95% accuracy.
But at what cost? I bet those chain of thought responses were super long.
Oh, absolutely. They were generating around 200 tokens per response.
Oh, wow.
Yeah. Now, if you look at the results for Chain of Draft in Table 1, both models achieved over 91% accuracy.
Pretty good.
Yeah, but they only needed around 40 tokens per response.
So an 80% reduction.
Yeah, it's an 80% reduction in output tokens.
That's huge.
It is very significant.
Did they also measure the impact on latency?
They did, and those results are equally impressive.
Okay.
Chain of Draft actually reduced the average latency by 76% for GPT-4o
What?
and 48% for Claude 3.5 compared to Chain of Thought.
So you're not just getting concise answers, you're getting them much faster.
Exactly. Much faster.
That could be a game changer for like real-time applications where every millisecond counts.
For sure.
Okay, so chain of draft sounds like it's pretty good at arithmetic reasoning.
Yeah.
But what about tasks that require more than just number crunching?
Right.
Like, more common sense reasoning.
Yeah.
How to do there?
That's where those common sense reasoning tasks come in. For this, they selected 2 tasks from the Big Bench benchmark: date understanding and sports understanding.
Okay, those sound pretty challenging.
They require the model to understand context and apply real-world knowledge.
Yeah, it's not just about, following a set of rules or crunching numbers.
Right.
It's about actually understanding the nuances of human language.
It is.
Okay, so how did chain of draft do?
So for the date understanding task, it didn't dramatically outperform Chain of Thought in terms of accuracy,
Okay.
but it did significantly reduce the token count and the latency.
So more efficient.
Yes, always more efficient.
What about the sports understanding task? Any surprises there?
So the sports understanding task is where things get really interesting.
Okay, I'm intrigued.
If you look at Table 3, you'll see that Chain of Draft actually surpassed Chain of Thought in accuracy
Ooh.
for both GPT-4o and Claude 3.5.
Hold on, so not only is it more efficient in this case, it's also more accurate.
Exactly, and the token reduction is even more remarkable. We're talking a 92.4% reduction with Claude 3.5.
Wow.
Yeah, so this seems to suggest that, in certain scenarios, encouraging this kind of conciseness can actually lead to a deeper understanding and even improved reasoning capabilities.
It's almost like it's forcing the model to really think about what's important.
Right, to distill the essence of the information.
Yeah, that's really interesting.
It challenges that assumption that more is always better when it comes to LLM outputs.
Right.
Right.
Okay, so we've seen arithmetic reasoning,
Yeah.
common sense reasoning.
Yes.
What about symbolic reasoning?
So for symbolic reasoning, they used coin flip tasks,
Okay.
where the model has to keep track of a sequence of actions
Okay.
and understand their symbolic meaning.
So it's really testing its ability to kind of manipulate abstract concepts.
It is. And while both Chain of Thought and Chain of Draft achieved perfect accuracy on these tasks, Chain of Draft again demonstrated its efficiency by using significantly fewer tokens than Chain of Thought.
Okay, so it seems like across the board.
Yeah.
Chain of draft is either matching or beating chain of thought in
Yes.
terms of efficiency, and sometimes even surpassing it in accuracy.
Right.
This feels like more than just, a small improvement.
It does.
Are we looking at a potential paradigm shift here?
Potentially, the researchers suggest that Chain of Draft could have a profound impact on how we design and train LLMs in the future. by encouraging them to, think more concisely. We might unlock new levels of performance and interpretability.
That's a really tantalizing thought.
It is.
Imagine, LLMs that are not only incredibly powerful and efficient,
Right.
but also easier for us to understand.
Yeah.
Their reasoning processes are laid out in a clear and concise way.
Transparency is key.
Yeah.
Definitely.
So this research has definitely sparked a lot of, excitement and debate
For sure.
within the AI community.
Yeah.
Some people think this is, a major breakthrough.
Yeah.
Others are maybe a little more cautious,
Right.
saying we need more research to really understand the implications.
Yeah. A healthy dose of skepticism is always good with
Yeah.
any new research.
Right.
However, I will say the results presented in this paper are definitely compelling.
Yeah.
And the potential benefits of chain of draft, I think, are undeniable. It really raises some interesting questions about the nature of intelligence, both artificial and human.
It makes you wonder if we can train AI to be more concise and efficient in its thinking.
Yeah.
Could we learn something from that ourselves?
That's the question, isn't it?
Could studying the principles behind chain of draft
Yeah.
actually help us to improve our own cognitive processes?
It's a fascinating thought.
All right, well, before we get too philosophical,
Okay.
let's bring it back down to earth a little bit
Right.
and talk about the practical implications of all this.
Okay.
So for our listeners out there who are, actively working with LLMs, building them, deploying them,
Yeah.
what are the key takeaways here? Should we all be rushing to, ditch chain of thought and switch over to chain of draft immediately?
I wouldn't say it's quite a drop everything and switch situation just yet. I mean, this is still a very new area of research.
Yeah.
And like with any groundbreaking idea, there's still a lot more exploration to be done.
Sure, but it's safe to say that chain of draft, has the potential to be
Yeah.
pretty significant development.
Absolutely.
Right.
I think this paper really presents a compelling case for the power of concise reasoning in LLMs. It's not just about efficiency.
Yeah.
It's about a fundamentally different approach to how we even think about the process of thinking itself.
Right, it's a meta thinking almost.
Yeah, exactly. And that has implications for everything from how we design and train these models
Yeah.
to how we interpret their outputs and integrate them into real-world applications.
So beyond just, plugging it into existing systems,
Yeah.
what are some of the bigger picture implications here?
I think that's what's so exciting about this research is that it really sparks all these new questions.
Yeah.
Like, for example, could we train models from the ground up? Using this principle of conciseness, could we bake the core ideas of chain of draft
Yeah.
into the very architecture of these models?
So we're talking about like a potential paradigm shift here.
Exactly. That's what makes this paper such a valuable contribution to the field.
Yeah.
It's not just an incremental improvement.
Right.
It's a fundamentally new way of approaching LLM reasoning.
So concise thinking, it's not just good for humans.
Yeah,
It might be the key to unlocking
it might be.
the true potential of AI as well.
Very well said. I couldn't agree more.
All right, well,
And for those of you in the audience who are already, deep in the world of LLMs,
Yeah.
I highly encourage you to experiment with chain of draft, test its limits, see what you can discover. The possibilities are really exciting.
Excellent advice. All right, everyone, that wraps up our deep dive into chain of draft, thinking faster by writing less.
Great paper.
A huge thank you to Salaju and the entire team at Zoom Communications for this fascinating research. And as always, we encourage you to check out the full paper
Yes.
for all the technical details, delve into the nuances of their methodology and findings.
And let us know what you think.
And be sure to subscribe to AI Paper Podcasts for more in-depth discussions on the latest and greatest in artificial intelligence.
Definitely.
We'll be back soon with another paper
Yeah.
that's pushing the boundaries of what's possible.
Always pushing the boundaries.
Until then, keep those models concise
Yeah.
and those algorithms humming.
Absolutely.